Howdy, AP PreCal. It is Ms. Kosh. We are continuing with the 2-5 notes on modeling exponential functions, or using exponential functions to model data, maybe a better way to say that. Okay, so I started a lovely video and then I got a little confused. I'm not going to lie, AP does things a little differently than I've done for the last 20 plus years. So when I saw this problem, I got a little confused and I started doing all this work, which I can talk about. But then I realized, oh, it wasn't as bad as I expected. So here's what they're telling us. First of all, they're introducing this value e, which I think you've seen in Algebra 2. It's an irrational number that's about 2.718. It's pi is irrational, e is irrational. I can show you where it comes from, and I'll go look and see if I have a video of that already, but it's cool. It's just not what I want to do right now. Okay, so I started doing all this work and I got really confused. I was like, oh wait, they need to be equal. I've got too many variables. What all is happening here? So I thought, well, okay, if this is my function b, then I could plug in 0, and what do I get? Anything to the 0 power is 1, so I just get 17. And then I came over and plugged in 1, and I got this lovely equation right here. And then I said, okay, well, if a and b are equal, then when I plug in 0, and then as I'm finishing all this up, I realized, oh, I could just use my properties of logs and write this and everything would be better. What I have is that this guy is equal to 17 times e to the, well, 0.31, all raised to the t power. So if I know what my exponents are, here's my a. My a is 17. My b is this e to the 0.31. Okay, I did all this work and didn't even need to. So a is 17. I'm going to tell you, we'll go ahead and say that b is equal to e to the, well, 0.31 power. Okay, so find the average rate of change from t equals 1 to t equals 7. So we are back doing average rate of change again. I'm going to come to my table on my calculator, clear out this previous stuff, and type in my b equation. 17 times, where is e? There it is. Was the natural log button. I don't know if you could see what I did. 0.31x. Okay, now I can take, on my table, I'm concerned about when t equals 1, which is this. So I have b of 1 is about 23.17, well, let's get a little more, 178,227. And b of 7 is, well, here's, I'll type in a 7, is about 148.8908.3. I'm tired of writing decimals. Oh, I'm so sorry. You couldn't see that I was falling off the page. And so now to find the average rate of change, I'm just finding the slope between those 2 points. So it's this 148.89083 minus 23.178,227 all over 7 minus 1. And I guess I should work that for you. So let's come back here. You know what I could have done? I could have, you know what? I'm still going to do it. Okay, I can go to this graph. Here's that equation. I'm drawing this graph. Ooh, isn't it lovely? I want to know G solve. I want to know when is it equal, what is the y value when x is equal to 1? And I got this 23 business. So if I come back here, will it remember that? Oh, you guys, okay. I wanted to store it as something. Oh, it remembers the x. It doesn't remember the y. Never mind. Okay, sorry. There might be a better way to do it, but I'm not remembering it currently. So let's just type in some decimals. 148.89083 minus 23.1. If I type something in wrong, hopefully you catch it and you know that I'm where I messed up. All over 6. Okay, so what is the average rate of change? We are increasing by just over 20 bacteria per hour. Is it bacteria? Yes. So the number of bacteria increases by just about 21 bacteria per hour. Okay, so then it says find the value of t when the bacteria in the particular culture is 1,000. So if I come back to my graph, I can hit draw. I can come in and do gsolve, and I have the option to do xcal, so I want to type in 1,000 for the y value. Is it in my range? Oh, it sure is. Okay, so t is about 13.1437 hours. So if we needed to convert that to hours and minutes, we could take this value, take that x value, subtract away the 13, so it's this fraction of an hour, so multiply that times 60. So it's 13 hours, it's about 13 hours and 8 minutes. Not quite, but that's good. Oh, sorry, you couldn't see what I was writing. That's good enough for our purposes right now. Okay, let's do this last one. So on this one, they've given us this lovely table, and they want us to do a regression. So I'm going to come into statistics. I'm going to clear out, hit delete, and get rid of all that. Well, I guess that was, okay. And I'm going to type in this one. So it's -1, 0, 1, 2, 3. And then 1, 2, 9, 51, 247. And now I'm going to tell it to graph. And there are the points. And I'm going to have it calculate an exponential function. Notice I have two choices. I can either use E or not use E. And so if you notice, my directions here said don't use E. So we're going to do that one. I can copy this into this equation, hit enter. I can draw it and see kind of how closely it follows some of those points. Notice it's not exactly, it doesn't line up exactly on those points, but it follows it pretty closely. Let me see if let's do this again so I forgot to write down my problem. So y, or f of x, let's call it f of x, is is approximately, but here's an equal sign, 2.8308 times, can you see what I'm doing? Sort of, 4.1610 to the x power. Okay, and then they say, so now I can come back here. It's both in my graph, but it's not on. So if I want to turn it on, I have to hit select. And then I could go draw this and then do a gsolve ycal when x equals 4. Oh, well, I need to change my domain. Or I can change my window, but I was too lazy to do that. Or I can come here, turn this guy on, come to the table, and then scroll down, and there's 4. So find the expected value when x equals 4. It's about, or we could say f of 4 is equal to, or nope, is approximately 848.5709. All right, good luck. Go study.